Hi, so welcome to the fourth lecture, which is about representing and interpreting the data. And this video is devoted to the measures of central tendency. And we are going to discuss two of them, which are mean and median values. So let's start with the former one, the mean. And when it comes to the sample mean, this is simply the average value of some indicator in your sample. So imagine that you analyze the value of age in a sample consisting of 50 people. So this is how you're going to denote the sample mean, x bar. xi stands for ith observation in a sample, and n stands for number of observations in a sample. So basically, in order to calculate average value of age in your sample, you will have to sum up ages of all the people constituting your sample and divide the obtained sum by their number, in our case 50. Population mean is calculated in the very same way, you just use slightly different notation. So for sample mean, we use x bar. For population mean, we use Greek letter mu. But the principle is the same. You sum up the values of certain indicator and you divide the obtained sum by number of people constituting the population. So let's consider calculating sample mean based on some very primitive example. So in our case, we deal with an extremely small sample consisting of 4 respondents. And we have information about their net income. In order to calculate sample mean, you have to sum up net income of 4 people and divide it by the number of people in a sample. So in our case, the sample mean value of net income is equal to 2,250 of some currency. Let's say 2,250 Polish zloty. So I believe it's clear, and let us proceed to another measure of central tendency, which is median. So analogously to mean, we distinguish between sample median and population median. So when number of observations in a sample is odd, that m is simply the middle number, and if number of observations is even, then sample median is calculated at the average value of two numbers in the middle. Okay. So let us use the same example as we used before. However, there is one important thing about detecting the median in a sample. So it's not a problem when you calculate the sample mean. However, if you want to detect the median value, you have to put all the values of the relevant indicator in the ascending order. So here, for instance, the value of income is not sorted. So you have 1500, then 2000, 3700, and 1800. So this way of data representation is not suitable for detecting the sample median value. That's why you should start with sorting the data. So this is what you've got. So you should start with the smallest number and end up with the biggest number. The next thing is that here, obviously, we have the even number of observations in a sample, like 4. And in order to calculate median, we have to pick two values in the middle and then calculate their average value. So we take those two values in the middle, we calculate their mean value, and we obtain the value of median. In our case, it's equal to 1900. Okay, obviously mean is not always equal to the median value. In fact, when mean value is equal to the median value, we are dealing with a symmetric distribution, which is not always the case. So there is some general rule regarding the value of mean and median, and we know that if data is symmetric, then mean and median value are typically equal or roughly equal. If data is skewed to the left, then median is bigger than mean, and if data is skewed to the right, then median is smaller than mean. So at this point, please just keep it as it is. Later on, by the end of this lecture, when we discuss how histograms are designed and what it means to be skewed to the right or to the left, it will become more clear for you. So thank you for your attention. That's it when it comes to the measures of the central tendency, and see you in the next video.